Hi, my name is Jan Gulbrandsen. I'm the President and Chief Engineer of International Test Instruments. Today I'm here to demo the 2500A PCI Express Protocol Analyzer. I will do an unboxing, describe what's in the box, what it can do for you in the lab. We'll also do a hookup in the lab so you can see how to connect it to the target system and also how to use this software. So let's get started. As it says on the box right here, this is a ITIC 2500A PCI Express Protocol Analyzer. This is a 2.5 gigabit per second by 4-lane protocol analyzer that can work with PCI Express generation 1.1, 2.5 gigabit per second. As it says here, PCIe 1.1, 2.5 gigabit per second. It can work in by 4, by 2, and by 1 link widths. It has a 2 gigabyte capture buffer inside. It uses a Cypress microprocessor, 48 megahertz clock frequency, and also an ARIA 2 GX FPGA from Altera. It has advanced hardware acceleration of protocol item detection. What that means is that the hardware inside will actually go in and scan the location of all the packets in the trace, so the PC software doesn't have to do that, and that's orders of magnitude faster than do it in software. It has an 8-level trigger, which allows you to trigger on up to 2048 bytes of data per trigger level, which is the deepest trigger level in the industry. And also it has a TTL compatible trigger in out port, so that's 5 volt compatible, and a by 4 active interposer slot probe is included in the box. So what you can do with this then is to debug your plug-in card designs for a basic PC platform running at PCI Express 1.1. Here's some description of the unique software features. It has pre and post trigger position, so you can trigger, you can either post fill or fill up to the trigger points depending on what you want to capture. So you can adjust the lane polarity, lane mapping, and the scrambling. I will talk about that later in the software demo. Dynamic on-demand data upload. That's a useful feature which allows you to only upload the data that is actually visible on the screen. So after a capture, you don't have to update the whole 2 gigabytes worth of trace data in order to view it, which means that the update of the screen after a capture will be very, very fast and almost instantaneous. You also have multiple time correlated views of the captured PCI Express protocol items. So that means you have a high level view of the protocol nesting. That means the transactions and the packets within the transactions. You also have a low level view which shows you the individual 10B characters on the link on the test. And I will demo that later so you can see how that works. You have a so-called node finder, which allows you to immediately find certain, or rather I should say all protocol items in the trace. So for instance, if you want to find all the memory read transaction layer packets, you can easily find those without searching. The hardware indexes all the locations to all the protocol items, so it immediately knows where they are without the software having to parse through the complete trace, and this is a lot faster than many other protocol analyzers. Because it indexes the location of the protocol items, you have instantaneous protocol item filtering. So the software essentially hides the packets that you don't want to view, and that's very, very useful because in the trace you have all the data. So afterwards, in case you want to only view some of the data, for instance, you might want to hide the skip ordered sets or all the DLLPs in the trace, you can easily do that and it's instantaneous to update the display afterwards. You also have XML and comma separated value, which is just regular ASCII format data export. So you can copy to clipboard and paste into another application, or you can export to XML and consume that data in some other custom application. And of course you have a print and print preview support as well. And this is where you can reach us. We're in Irvine, California, in United States of America. And of course, it is CE approved and does not use any harmful things for nature. So let's open the box and see what's inside. So first of all, when you open it up, you will see a letter thanking you for buying this from us. And it essentially says there, thank you for purchasing the 2500A PCI Express Protocol Analyzer, the smallest yet one of the most innovative 2.5 gigabits per second PCI Express Protocol Analyzers on the market. And also it points out many of the unique features not available in other PCI Express Protocol Analyzers, which is the Protocol View, which organizes the data fully hierarchically. And that means that it's a very intelligent view. I'll explain that later in the software demo. But the data view actually organizes all the packets within the transactions that they belong to. So for instance, if you have interleaved I/O transactions, for instance, to a disk drive that they're reading and writing and so forth using queued commands, all of the packets that belong to the one particular transaction will be grouped together. So it's very easy to see where the packets belong to. It's not kind of like others older protocol analyzers. Sometimes it was really hard to see where different packets belonged and how they were associated with each other. But this software makes it very, very easy to do that. It also has the hardware, FPGA hardware acceleration of protocol item detection. I talked about that. The dynamic on-demand data upload. I mentioned that also. You have the extremely deep trigger sequence detectors. This is an interesting feature of the FPGA used. It has onboard RAM in the FPGA and lots of it. And we use that to, in real time, monitor the data stream that goes through the analyzer. And we can actually capture up to 16 kilobytes of real-time data and compare it to what's in the trigger sequencer. So regardless how much data you want to use as your trigger criteria, this unit can help you with that. Many other units only allows you to trigger on maybe 4 D-words worth of data, and there's really no limitation at all in this unit. To install the hardware and software, follow the instructions in the user guide, which is on the enclosed CD. And of course, you can email us if you have any problems getting started. So let's see what's in the box here. First of all, you have a CD which contains the drivers and software. This software runs on Windows 32-bit and 64-bit Windows. Anything newer than Windows XP will work just fine. It only requires 15-year-old PC. So if you have anything that runs Windows XP with a 1 gigahertz processor, it will run this software just fine. Also inside the box then you have the unit, the Protocol Analyzer unit, of course. Let's open it up to see what it looks like inside. So at the front end, you have the a power LED, which turns on as soon as you have probe power. So this analyzer, it uses power from the target system via the probe. So you don't need anything special to go to the field. This is a pocket-sized analyzer. It almost fits in my shirt pocket, but you need a little bit bigger pocket for that. But it's actually the smallest PCI Express analyzer on the market today, and it's very, very light. So this one will easily slip into your laptop bag. And also you have a activity LED on the front panel, which flashes whenever there is a packet detected on the link under test. On the rear of the unit then you have the USB 2 connection to the analysis PC, which runs the software then. And also you have a trigger port that can be triggered, used as an input or output trigger port. And there is an adapter in the box here that will allow you to connect this to a regular BNC cable to your oscilloscope or logic analyzer or any other equipment you want to hook up. I'll talk about that a little bit more in the lab session, where you can see how all this fits together. So also in the box you have the active interposer probe, which then allows you to debug let's see, I can get this out, which allows you to debug a plug-in board or a add-in card for a regular PC. So of course then you plug this into your motherboard. I'll show this in detail later in the lab session, how to do this. But for now, let me just say that you insert this between your motherboard and the device on the test you want to debug. And also you have the by 4 PCI Express connector, and you can see here, if you look carefully, that well, maybe it's hard to see, but the end, there you can see it, the end of the connector has been opened up. So if you have a PCI Express card that you want to debug that's longer than a by 4 connector, you can still fit it, because it will just extrude a little bit further from the end of this connector. So you can debug up to by 16 graphics card if you need to do that. And of course then the link will be down negotiated from the by 16 to a by 4 link, because that's all the probe passes through. So I will talk about that more in the lab session. Also in the box here, if we dig down a little bit, you get some more items. You get a USB cable, high quality USB cable for the uplink. You get a trigger adapter for the rear trigger port, which connects to a BNC. And you have 2 different, a long format and a short format bracket for the interposer probe. And also, of course, you have the Molex external by 4 cable. This is a quality cable from Molex that ensures that you don't have any issues with the connection. So that's pretty much all for the unboxing. So I'm going to set things up in the lab, and then we can see how to use this unit to capture data. I have here in the lab set up the needed equipment to test the 2500A Protocol Analyzer in the typical development setup. You have here a regular PC motherboard, which has the PCI Express active interposer probe from ITIC inserted into the motherboard, and on top you have a regular SAS and SATA host bus adapter, which is then connected to an external hard drive. And I have running on this PC a IO meter application, which measures the throughput while doing write, reads, and compares to the hard drive. So then, by using the protocol analyzer, we can then see the data being written and read from the drive and see exactly how the computer does that. And here we can see a zoom in of how things are connected into the PC. So here is the active interposer probe, and here is the host bus adapter. This is the cable that goes to the hard drive being written and read from, and down here is the cable that goes from the interposer probe and up to the protocol analyzer. And there you can see another view of the data connection. The probe is below here, and this is the external Molex cable. Is 3 feet long, or 1 meter, and it goes here into the protocol analyzer. The protocol analyzer is then connected to the analysis PC, which runs the software using this USB 2 cable. And here we can see how to capture the data. You simply set up the capture using the capture menu, which here set the capture buffer size to 1 gigabyte and a by 4 link width. We set the trigger position to the beginning of the capture buffer so we can see data afterwards. By default, the trigger is set up here to trigger on anything, so any packet that flies by will capture the trigger, or trigger the capture rather. So in here in the trigger menu, you can see that it is set to trigger on anything. So we could change that to trigger on a, for instance, a any TLP that is detected on the link, and we start the capture. You see now here that it's downloading data to the protocol analyzer, so it actually loads the FPGA and configures all the trigger sequencers now, and you can see now it's already triggered. The post-processing is doing the scan of the trace memory to find all the protocol items. So at this point now, all the protocol items in the trace have been already identified and located. So here you can see that you have hosted device TLPs 21,000, device to host protocol items 145, and so forth. And you can also drill in here and check for individual packets. So for instance, if you want to see the first mem-read TLP packet that was detected in this trace, you just click on here, and because we set up the trigger to trigger on TLPs, this is also the trigger location. You can see here on screen. If you want to click to the next packet in the trace, then you go to next here, and so forth. You can also hide packets of a particular type by right-clicking on the packet in the protocol view and just select hide protocol items of this type. And then you can see here that it will also shown as hidden in the node finder. So you can unhide either here, or you can go and right-click in the protocol view and show all protocol items. So for instance, now if we want to only see the TLPs that are written and read to the hard drive, since we're doing a write, read, compare, then we can hide everything that's not related to that. So all the DLLPs we hide. We click do that a few times to get rid of them, because they are both upstream and downstream DLLPs. And what's left then are the packets that are related to the actual reads and writes. So here you see that there's still a skip order set. We can hide those two, and what's left are simply the reads and writes. So here you can see that there was the host bus adapter asserted interrupt, and then deasserted interrupt after being serviced, and then the data was written from the host to the device 512 bytes at a time. And you can also then open the transactions and see individual packets that are part of that transaction. So you can see here that the drive requested data to be read from the host, and it requested 500 bytes to be read from the host memory and be sent to the device. And you can here see that the host responded with 4 64-byte packets, and here you can see that the device acknowledged those packets, and then the host sent more data and the device acknowledged, and so forth. So all the packets are in here. Is the initial request TLP, and then you have a bunch of completion TLPs and the associated acknowledgements to these individual TLPs. And this is how the 2500A Protocol Analyzer is quite different from many others on the market, is because everything is neatly organized underneath here, so you can see exactly the packets that are part of a particular transaction. And you can see here then that the sequence number of that transaction is the same as the sequence number of the TLP that initiated the transaction. And also you can see here that the data has not yet been uploaded from the actual hardware. So the data you're seeing on the screen here is actually residing inside the trace buffer inside the protocol analyzer, and only as much data as is needed to actually display the screen is updated or uploaded at any time. So when you are scrolling through the trace here, you go all the way to the end of the gigabyte capture. You can go scroll up, we can go to the beginning and end. This is in real time uploaded from the 2500A Protocol Analyzer. And this means that even for a full 2 gigabytes transfer, you do not have to wait for all the data to be uploaded, which can be kind of slow operation over USB 2. It takes about a minute or two to upload a 1 or 2 gigabyte trace, so it's not that bad. But if you want to see data immediately, this allows you to do that after a capture. So now, for instance, if you want to save the trace and upload all the data, you can just save it as a temp file, temp PCIe file, and you save it. And then you can see now that the upload takes about 1 minute, because right now the whole 2 gigabytes worth of data is being uploaded through the link and saved on the PC. And had you not had the dynamic data upload, then you would have to wait for this upload to take place every time you capture before you could analyze the data. But because you have the dynamic data request and the dynamic data upload from the software, then the software is intelligent in that it only requests the data that is actually needed. So you will never see any slow data uploads take place unless you actually decide to save the full trace to disk. And also now the data is being saved on the hard drive in this computer, which is a slow hard drive. It's 5400 RPM hard drive on the laptop. It's also a rather slow laptop, so you'll most likely see an upload that's a little bit faster than this though. But now the data has been saved, so you can now, if you want, open the trace again from file, and this is how long it then takes to display an already captured buffer. So it's instantaneous. And also, if you want to hide and unhide protocol items like this, you can see that the display updating is instantaneous. It goes very, very fast because you don't have to wait for the software to find the locations of various protocol items, because it already has indexed that when the file was uploaded. So here you see again with irrelevant items filtered out, and what's left is only the read and write transactions. So this is a quick overview of how you actually do a capture and do a quick analysis. In the next section I will go through this software in more detail so you can see all the features and learn more about the capabilities of the 2500A PCI Express Protocol Analyzer. So I also want to show you the software for the advanced 2500A PCI Express Protocol Analyzer, and that is running here. There are a lot of features in this software that will be part of the new 1480B USB analyzer design, so therefore I want to show you the features in this software, since they are essentially the same and will be ported over to the 1480B. So I have here a already saved capture that I've taken previously from a target system. So we can just open that trace and take a look and see how the user interface works, and what features are available and how they are improved compared to the older 1480A USB Protocol Analyzer, which I showed you the software of before. So it's filtering the protocol view. Essentially, it's building the protocol view from the 2 GB worth of data, and that only took a couple of seconds. And here we can see that immediately here you see a similar view to the USB Protocol Analyzer, in that transactions and packets, or rather I should say the packets are displayed within higher level transactions. So that means that, for instance, if there are a lot of packets going back and forth, they're all being neatly organized under the transaction that the packets belong to. And here you can see the scroll features, and this is part of the dynamic data access that this protocol view does. It has actually, the software has created an index of all the protocol items in the whole trace, the whole gigabyte, the 2 GB worth of trace memory. And because of that, you can immediately go from the beginning and scroll to the end like this without any delay whatsoever. You don't have to wait for any decoding. The data is right there to be viewed. So just like in the 1480A USB analyzer, you have a details view which shows in either text form or decoded packet form exactly what data you are looking at. A new feature available in this software that will be available in the new USB analyzer software is that you can now go in and select here a number of fields in a packet, and the corresponding location of that in the raw data will be displayed in the lane view. So here you can see that this packet, you can actually do a select all even. You can see that this packet is a device to host packet, which is also shown in the protocol view. Here you can see that there's a left pointing arrow, that the left pointing arrows are the packets going towards the host. So you can imagine that the host is up here on the left side and the devices are to the right. So this goes from the device to the host, and this from the host to the device. So that is a new feature that will be part of the 1480B advanced USB Protocol Analyzer. You can also see that you have the same kind of payload view as in the USB analyzer, but you can also copy to clipboard. You can select copy to clipboard, and then you can paste it in some other application like Notepad, and everything will be copied over. The copy to clipboard also works for in the protocol view. You can just mark up the beginning and the end, and right click and copy to clipboard, and then paste it in wherever you want. So all these fields then you see up here will be copied to a clipboard. You can also do data export via XML, and to do that, if you try to export right here, you will get a warning saying that you have to assign 2 markers in the protocol view, and that will be the beginning and end markers which define then what data to export. So you can just add a marker, and you can say export start, and then you add a marker down here that says export end. And as you can see, you can also choose the color now in the more advanced software. So we set it there. So now we want to, since we have the markers defined, you can either export the data between this marker, or you can actually print the data between this marker. So if we first do the export, you select the export protocol view items, and then you say that you want to export between export start and export end, and then you click export to XML and you put it on disk. Oh, you have to say a file name here too. Exported, and you save that, and it's done. And then when you open that file, then you will see all the data in XML format, so you can actually get all the information that's available here, including all the details information available in all the details view and so forth. So the exported XML data contains all the data available in the trace between these 2 markers, so you will not lose any information by doing an export. And that means that you can grab the data and process it in your own application afterwards without losing any part of the data. Since we have markers defined, we can also then do a print on it. So what you can do then, you select your printer, and you select the markers which define the beginning and end of the data to be printed, and you can actually do a print preview here. And this is very fast. The 1480A has a very simple print engine. This one is vastly improved, so you can print very quickly, and you can actually also drag this window around. See if I can resize it here. If you make it smaller, see, zoom 150. But as you can drag it around and look at the details, you can move to the next and previous page and so forth. And when you're ready, you can just print it. And of course, you have the regular page setup and so forth. So this is a much more advanced print engine than the previous one in the 1480A USB Protocol Analyzer. So the plan then is to move this over to the 1480B, so you get that functionality in the USB Protocol Analyzer too. If we then look closer in these pop-up menus that occur, you can see that you can hide and show protocol analyzers. So if we go, actually previously when I saved this trace, I have hidden a number of packets in the trace that are not interesting to view. And here you can see the checkboxes here are actually, some packets are hidden. You can go in and say which ones. In particular, the update flow control, the FCP and FCNP, posted and non-posted, have been hidden. So you can actually unhide, and those will show up here. Or you can just hide them again, and they will be gone. So this is something that's vastly improved from the 1480A, and this feature of individually hiding and showing packets, and as you can see, it's very fast to show and hide packets because all the packets in the whole 2 gigabyte trace RAM have already been detected, so the software is aware of their location within the trace. So this is immediate the filtering functionality. So what you can do is you can show all items again, and you can see that this is the beginning of 2 gigabyte, this is the end. You can scroll through it all without any delay whatsoever. So then if you want to only see the data transfers again, you can go in here and you can hide the DLLPs. You can hide this DLLP too. You can right click, go hide, skip ordered sets, hide those. You can hide the ones that go the other direction, and then you can get rid of these two. And you have a couple more, there are different versions of them. And here again you have the resulting trace. So it's very easy and very fast to show and hide protocol analyzer, protocol items in the trace. So this feature of hiding individual tree nodes or protocol items via the node finder is something that is planned to be integrated into the more advanced USB 2 1480B Protocol Analyzer 2. You have the copy to clipboard again. You have the select all. Of course, the trace is very big. There are about 26,154 rows here, so you probably don't want to do that. You could if you wanted to, but as you can see, it takes some time. So selecting and copying the clipboard is recommended only to do for fairly few protocol analyzer items. If you want to export a larger range, then you should define markers in the protocol view like these, the start, let's see, these two, the start and the end, and then export using the export to XML functionality. That is a lot faster. You have edit, delete, and delete all markers. You have a search payload. And as you can see here, it looks quite similar as the 1480A search payload data dialog. One addition here is you can search either link direction or both. And also the searches here are actually done on a background thread. So if you search for something that you know is not there in the trace, the search would then be kicked off, like you see here, on the background thread, and you can continue working, analyzing your trace while this is going on in the background. Markers view, I already showed you that. Whenever you click on a marker, the protocol view will change to that location. You can also here do a set the time reference, and then of course it would change up in the protocol view, in the markers view, as well as in the lane view down here. I should say that the lane view is showing the data exactly as it happens, or as it was transferred on the link and the test. So see if we can get one of those skip ordered sets here. There was something there. Nope, this is a actually it's a packet in that location. Get another one. Yeah, maybe that was a skip ordered set. Yes. So here you can see all the way to the lowest level. For instance, here there is a skip ordered set that goes from device to host, and of course it sends the skip characters on all 4 lanes in parallel. We talked about searching, the printing and exporting, and set and clear time reference. That's about the same as in the 1480A USB Protocol Analyzer, so I'm not going to talk too much about that. The context menu also appears here, but of course if you do something in this view, you will actually export data. For instance, if you try to export lane view items, then you export from the lane view instead of the protocol view. So you can actually export the raw data to XML2, or you can export the protocol view data to XML. And of course you can select and copy to clipboard as well, or print it. Another thing here in the PCI Express Analyzer 2500A is that you can select the trigger position within the capture buffer. So here you see that the capture buffer size is 2 gigabytes. That can be changed to something a lot smaller in case you want to save smaller data files, you know exactly what you're looking for. And you can set up the trigger to trigger on that. You can set the trigger point then to be at the beginning or at the end of the buffer. So for instance, if you want to trigger 50% of the trace, or you want to capture 50% of the trace that are before the trigger point and the rest after the trigger point, you just set the slider in the middle. So if you want the trigger position in the beginning, you set it somewhere here. Link width should match whatever your link width is on the bus under test. And as you can see below, the sample trace here used a 4-lane link, and you can individually invert the polarity on any of these links, or lanes I should say, in case it's inverted on the physical lanes. And the lane mapping then could be standard or reversed, so or even custom. You can drag and drop like this. You put it over here or put it back. So it's quite flexible. So that's the capture configuration. You also have a trigger configuration up here, and this is very advanced 8-level sequence detector. The Area 2 GX FPGA in the 2500A PCI Express Protocol Analyzer has quite a lot of onboard RAM, which allows us to define very deep sequence detectors. So let's go and copy this to a custom sequence, and then you can see that you can, for instance, this one that was predefined would trigger whenever an STP control character is detected on lane 0, and that would be then any STP packet. Or any TLP, I should say. There are two kinds of packets, TLP packets and DLLPs. So this is the TLP, and you have a token called SDP, and that's the start of data link layer packet, and this stands for start of transaction layer packet. As you can see here, you can define up to 2048 custom characters, so you can pretty much trigger on anything. And you can also define the sequence. You say, for instance, that 250 or up to 2K should look like this, but only in the host to device direction. And then you can define the next level to use sequence detector 1, and you go in here and you do the same thing. You define whatever should be detected for that level. And you have 8 sequence detectors, 0 to 7, which means that it's quite flexible what you can trigger on. And you also have a trigger port configuration. and that is, of course, determines the rear trigger port here, what should happen in regards to that. So you can either trigger in or trigger out whenever the trigger sequencer. So if you trigger in, then that will trigger the capture and you would stop the software at that particular time. If you trigger the out, then the sequence detector here will trigger the analyzer and it will assert either high or low on the trigger output. And you start and stop the capture up here, of course. Updates, go to our software. Consulting, we offer consulting services for anything related to peripheral device and device driver consulting. And that's through my sister company, Summit Soft Consulting. So we offer Windows device driver, board design, printed circuit design, circuit board design, SI/PI integrity analysis, and so on and so forth. And then, of course, you have the About box right here. So as you can see, there are a lot of features that have been added in this software, not available in the 1480A USB analyzer. Most notably, it's the trigger sequencer. The 1480A does not have a built-in trigger sequencer, so you capture the data and you have to analyze it and look for what you're looking for afterwards. So that's one major feature that will be part of the 1480B. Another one is the printing is vastly improved, and you have the XML exports, which is the third-party interaction with your own application. You can parse and process the data after it has been captured. The 1480A did not have export functionality built in. And of course, you have the drag and drop functionality of the views, which is sometimes very useful. Sometimes you want to view, for instance, payload and the lane view at the same time, then you can drag it over here. You cannot do that in the 1480A because both of those views were stuck on the same tab down here. So now it's more flexible to move things around. And again, the hardware protocol item acceleration, which is the feature where the hardware actually detects and generates the location and information about all the protocol items in the trace. That's what allows the search and sorting and hiding to be instantaneous like this. And you need already hardware indexed locations of all the protocol item locations to be able to do search this fast. Notice that this is a full 2 GB trace that is on the fly being filtered like this. And you can then again go to the beginning, go to the end. You have all the data right at your fingertips. And you can also do it from here, of course. You can hide and show. So if you only wanted to show the HD TLPs, then you would uncheck this. Here you can show all the packets again, show all those packets. You can hide anything related to device to host direction, goes towards the PC. Then this is what's left in the trace. So it's very, very flexible, very fast, and has been optimized to work together with the hardware for a maximum speed and flexibility. And most of these features will be ported over to the 1480B USB Protocol Analyzer. That pretty much sums it up. Thank you very much.